to our video on energy efficiency in buildings. In this training, we'll explore how improving buildings' energy efficiency can lower costs, reduce emissions, and enhance comfort for occupants. We'll also look at major European Union directives, discuss strategies for both new and existing buildings, and share inspiring case studies. By the end of this video, you will have a better understanding of the importance of energy efficiency in buildings, EU and national objectives in the medium and long term, both energy-related and non-energy-related benefits of efficient buildings and main retrofitting technologies, the relevance of different building parts and equipment in overall energy demand and consumption, efficient systems and equipment to reduce and satisfy building energy demand, and the electrification or decarbonizing of heat production. EU political and legal framework. Buildings in the EU account for around 40% of total energy consumption and over 1/3 of energy-related emissions. Because roughly 85% of buildings in the EU were built before 2000, many are inefficient. This presents both a challenge and a huge opportunity for saving energy. To address this, the EU has introduced legislation like the Energy Performance of Buildings Directive. This directive pushes for stricter energy performance standards for new buildings, mandatory improvements to existing buildings, and better indoor air quality and the adoption of digital energy management systems. Ultimately, the EU wants to achieve a fully decarbonized building stock by 2050, making buildings more affordable to heat or cool, less vulnerable to price shocks, and more environmentally friendly. Approaches to building energy efficiency. When we talk about energy efficiency in buildings, think of these 5 steps. First, smart design. For new buildings, follow local building codes and focus on orientation, climate, and efficient layout. Second, low-carbon building materials. Whether new construction or retrofitting, choosing materials with low embodied energy can cut overall emissions. Third, high-performance envelope. Minimizing heat flow through walls, roofs, and windows is crucial. Fourth, efficient systems. Heating, ventilation, and air conditioning, or HVAC, should use as little energy as possible, often through renewable heating and cooling, and well-designed controls to satisfy comfort standards while avoiding excessive energy losses. And finally, user-friendly controls. To allow occupants to easily regulate temperature, ventilation, and lighting to keep consumption in check and use those systems only when necessary. Following this one-direction path, starting with the building envelope, then addressing systems, and finally optimizing controls, ensures maximal savings and comfort. Building envelope. The building envelope includes exterior walls, roofs and foundations, and windows, doors, and any openings. Up to 80% of a home's energy demand can go toward heating and cooling. A high-performing envelope helps keep warm air in during winter and out during summer, directly lowering HVAC costs. The key elements are insulation. Materials like rock wool, fiberglass, or wood fibers slow heat transfer. Insulation can be placed internally, cheaper, but reduces interior space, or externally, more expensive, but highly effective. And windows. Window selection greatly affects solar heat gain and overall heat loss. Double or triple glazing, airtight frames, and shading devices can dramatically reduce energy loss. Building envelope upgrades can cut heating and cooling needs by up to 80%, an enormous energy and cost reduction. Retrofitting existing buildings. Because many structures are older, retrofitting is a central priority in the EU's Green Deal. Retrofits can be complex and pricey, but they yield immediate benefits, such as reduced emissions, lower energy bills, and increased comfort and indoor air quality. Governments across the EU provide financial incentives, like grants, subsidies, or tax breaks, to encourage retrofitting projects. These often target the worst-performing buildings, public buildings, and upgrades to heating and cooling systems. Even partial renovations, like adding external insulation or upgrading windows, can significantly improve a building's energy rating. HVAC systems and district heating or cooling. Heating, ventilation, and air conditioning, or HVAC, often represents the largest share of energy use in buildings. Efficient HVAC systems can drastically cut both costs and emissions. Let's break down a few options. The first one is district heating and cooling, or DHC. It delivers heated or cooled water to multiple buildings or entire districts. Newer fourth and fifth generation systems allow the integration of waste heat from data centers or factories, or renewable sources like shallow geothermal or solar. They operate at lower temperatures, making them more efficient and flexible. It could require modifications in heat emitters in old buildings. The second HVAC system is boilers, which traditionally are fueled by fossil fuels, but can also use biofuels like pellets, biogas, or biomethane. Upgrading or converting older boilers to bio-based fuels supports local economies and cuts emissions. And lastly, heat pumps. Instead of burning fuels, heat pumps use electricity to move heat from one place to another. Air to air, air to water, or ground to water varieties exist. Some achieve efficiencies 2.5 to 5 times better than boilers. Pairing a heat pump with renewable electricity yields near zero emissions for heating and cooling. By adopting these efficient heating and cooling technologies, buildings shrink their carbon footprint and operate more cheaply over the long term. Additional energy-saving devices and practices. Beyond upgrading envelopes and HVAC, other devices can further cut energy use. For example, heat recovery in ventilation, which recovers thermal energy from outgoing stale air to preheat or pre-cool fresh incoming air. Another option is demand-controlled ventilation, which modulates airflow based on indoor CO2 levels or occupancy, so you can never overventilate or waste energy. Next is variable speed drives, or VSDs, that adjust the speed of fans and pumps based on real-time demand, saving electricity. There is also free cooling, which utilizes cool outside air during mild weather and overnight hours to reduce chiller operation. And finally, recommissioning, a thorough checkup of equipment and control settings, ensuring your building runs optimally. This often uncovers easy no-cost or low-cost savings. Case studies. Here, we present 2 interesting case studies from Spain. Case Study 1, Gijón, Asturias, partial renovation of a historic protected building. Built in 1914, this building was abandoned for 20 years, initially labeled Energy Class F. The retrofit included internal insulation to preserve exterior aesthetics, new windows, and a radiant floor system. As a result, heating demand was down by 82%, total energy consumption was down by 87%, and the building received an upgrade to Energy Label A. Case Study 2, Lloreta, Basque Country, ultra-low temperature district heating and cooling. A cluster of 14 buildings originally used diesel oil boilers, which were converted to a 40 to 45 degrees Celsius network plus water-to-water heat pumps for higher temperature needs. As a result, greenhouse gas emissions were reduced by 35%, and renewable energy use soared by 350%. This case demonstrates how district systems and waste heat can make communities more efficient and sustainable. As we've seen, energy efficiency in buildings isn't just about saving money. It's a cornerstone of the European Union's path to net zero emissions by 2050. Whether you're planning a new building or aiming to retrofit an existing one, we recommend that you focus on a high-performance building envelope, efficient heating and cooling systems, and smart ventilation and controls. This will lead to lasting benefits in comfort, air quality, and overall sustainability. Additionally, we encourage you to stay informed about new technologies and funding opportunities in your region, collaborate with local experts, policymakers, and community members to support greener buildings, and take action by investing in energy efficiency measures that pay off in healthier spaces and a cleaner future. Thank you for watching, and we hope you're inspired to make our buildings, cities, and planet more sustainable for generations to come.